Okay, ji. Assalamu alaikum. Everyone can see this slide. It's not basically slide. It's I have opened up the book, so everyone can see this heading 9.3 principal stresses and maximum in-plane shear stress.
Yes, sir.
Okay, so we will start with this heading 9.3, that is principal stresses and maximum in-plane shear stress. Yesterday we have studied about the principal planes, and we have said that maximum stresses, maximum magnitude of the normal stresses, that is maximum positive and maximum negative. Maximum positive is your major principal stress and negative is minor principal stress. We said that major principal stress and minor principal stress, they will act the principal planes. And the other point which we said that
Excuse me, sir.
जी
Sir, you haven't started recording.
हाँ मुझे भी यही है सॉरी जस्ट अ मोमेंट Okay, ji. Let's start with our lecture about principal stresses and maximum in-plane shear stresses. Yesterday we have studied that maximum normal stress and minimum value of minimum magnitude of the normal stress. They will occur at the principal planes. ठीक है जी. So maximum normal stress is basically over major principal stress, and minimum normal stress is over minor principal stress. So major principal stress and minor principal stresses, they will occur, or they will be over the principal planes. Now, other thing we have said yesterday, that over the principal planes, maximum shear stress will be zero. Now, the thing is that we need to calculate the orientation of the principal planes. Orientation of the principal planes. Once we will have the orientation of the principal planes, theta p1 and theta p2, then we can put these values of theta p1 and theta p2 separately into equations 1 and equation 2, which we have derived for the calculation of transformation of the normal stresses sigma x dash and sigma y dash. Fine. So now first objective is to calculate the orientation of the principal planes theta p1 and theta p2. So let's start with the derivation, that how we come up with this equation. So in the book, equation 1 is for the calculation of the transformation of normal stress is sigma x dash, and equation 2 is calculation of the transformed shear stress is tau x dash y dash. Just for your reminder, that in over case I have numbered sigma x dash as equation 1, sigma y dash as equation 2, and tau x dash y dash as equation 3. So it can be seen that the magnitudes of sigma x dash, sigma y dash, tau x dash, y dash, these are basically over transformed normal stresses and shear stresses, and their values, their magnitudes depend on the orientation, angle of inclination theta of the planes on which these stresses act. In engineering praxis, it is often important to determine the orientation of the element that causes the normal stresses to be maximum and minimum. So basically, we want to know the orientation of the principal planes over which you will have maximum, what you say, normal stress, major principal stress, and minimum normal normal stress, that is minor principal stress. So it is often important to determine the orientation of the element that causes the normal stress to be a maximum and minimum, and the orientation that causes the, now this is one step, that we have to calculate the orientation of the principal planes. This is one step. And the orientation that causes the shear stress to be maximum, that is the second step. That is, we also need to calculate the orientation of the shear planes over which we will find the value of the maximum shear stress. So today we will first derive the equation for the calculation of orientation of principal planes, over which you will have major principal stress and minor principal stress. And then we will calculate the orientation of the shear planes theta S1 and theta S2, over which you will have the maximum shear stress. Is this point clear? Okay, let's start with this derivations. The things will get more clear. So now in plane principal stresses. So now first objective is to calculate the orientation of the principal planes. And the second objective of our today's class will be to calculate the orientation of the shear planes. So in plane principal stresses. Now, to determine the maximum and minimum normal stresses, that is to determine the major principal stress and minor principal stress, we need to differentiate equation 1. Equation 1 is over equation which is sigma x dash is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau xy sine 2 theta. It is this equation, guys, which we have derived earlier. This one, sigma x dash is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau xy sine 2 theta. So to calculate the orientation of the principal planes, what we have to do, we have to differentiate equation 9.1 with respect to theta, and then we will simplify the equation Okay, Ji. Guys, is this slide clear? Can you see this slide?
Yes, sir.
Yes, sir.
Okay. Now this is our equation. Sigma x dash is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau xy sine 2 theta. ठीक है जी? So this is my main equation. So I have to differentiate this equation with reference to theta. So when I will take the derivative of this, sigma x plus sigma y over 2, so there is no theta, so this term will be 0. So next is uh, sigma x minus sigma y over 2, derivative of cos is minus sine 2 theta into the coefficient 2 plus tau xy, derivative of sine is cos, ठीक है जी, into the coefficient 2. So my derivative will become sigma x minus sigma y over 2 into minus sine 2 theta times 2 plus tau xy cos 2 theta into 2. ठीक है जी? So this derivative is clear.
Yes, sir.
So next is we can just simplify this derivative. Delta sigma x dash over delta theta is equal to sigma x minus sigma y. minus sine 2 theta. This 2 and this 2 will cancel out. Plus 2 tau xy cos 2 theta. ठीक है जी? This point clear? This point clear?
Yes, sir.
Next is we have to equate the derivative equal to 0. So we have to equate to 0. So this will become 0 is equal to minus sigma x minus sigma y sine 2 theta. This minus sign is taken outside. Plus 2 tau xy cos 2 theta. Then I have taken this minus sign on the other side. So this has become sigma x minus sigma y sine 2 theta, which is equal to 2 tau xy cos 2 theta. ठीक है जी? Then I have to rearrange the coefficients in such a way that sine 2 theta over cos 2 theta. ठीक है जी? Because sine 2 theta over cos 2 theta will be over tan 2 theta. ठीक है जी? And this is sine 2 theta over cos 2 theta is equal to 2 tau xy over sigma x minus sigma y. And further simplification yields that tan 2 theta is equal to 2 tau xy sigma x minus sigma y. ठीक है जी? So guys, please take few minutes and do this derivation yourself as well, and let me know if you have any difficulty. So the final expression for the computation of the orientation of the principal planes, this there will be in subscript theta p. ठीक है जी? So tan 2 theta p is equal to 2 tau xy over sigma x minus sigma y. जी, everyone is fine with this equation? So this is the final equation for the computation of orientation of the principal planes, over which you will have major principal stress and the minor principal stress. ठीक है जी? Tan 2 theta p is equal to 2 tau xy over sigma x minus sigma y. So it means if you have shear stress and the normal stress, you can calculate the orientation of the principal planes. Okay. Now this equation tan 2 theta p is equal to 2 tau xy over sigma x minus sigma y. Now this equation for the orientation of the principal planes has two roots. ठीक है जी? It has two roots or two solutions, you can say, theta p1 and theta p2. ठीक है जी? This solution will have two roots, that is theta p1 and theta p2. Specifically, because this is tan 2 theta p, so specifically the values of 2 theta p1 and 2 theta p2, they will be 180 degrees apart. ठीक है जी? So 2 theta p1 and 2 theta p2 from this equation that you will get, they will be 180 degrees apart, exactly 180 degrees apart. So theta p1, which is half of 2 theta, so theta p1 and theta p2, they will be 90 degrees apart. ठीक है जी? So when you will solve this equation, ठीक है, when you will solve this equation, you will have two roots, theta p1 and theta p2. Specifically, the values of 2 theta p1 and 2 theta p2 are 180 degrees apart. So theta p1 and theta p2, they will be 90 degrees apart. ठीक है जी? Is this point clear? Now the next thing is next thing is uh, that these are like four quadrants. ठीक है जी? So you guys know that in this quadrant, let's say this is my first quadrant. In this quadrant, uh, tan will be positive. ठीक है जी? Tan theta will be positive. ठीक है? In this second and third. In this third quadrant, tan theta will be positive. In this second quadrant, your sin theta will be positive. ठीक है जी? ये फर्स्ट क्वाड्रेंट में तो सब पॉजिटिव होते हैं, sin theta, tan theta, cos theta. In the second quadrant, sin theta is positive. In the third quadrant, tan theta is positive. In this fourth quadrant, cos theta is positive. ठीक है जी? Now, when we say that we will, this solution will give us two roots, that is theta p1 and theta p2. So, 2 theta p1 and 2 theta p2, which will be 180 degrees apart. So 2 theta p1 will be, let's say, in the first quadrant, and 2 theta p2, which is 180 degrees apart, that will be in quadrant number 3. Now the point to be noted here, that in this formula you can see both of them are both of them can either be positive, like tau xy, 2 tau xy over sigma x minus sigma y. Both these quantities can either be positive, or both these quantities can either be negative. ठीक है जी? Let's say if you will have minus tau xy over minus bracket sigma x minus sigma y, minus minus will cancel out. ठीक है? So both these quantities can either be positive or negative. ठीक है जी? The values of theta 1 must theta p1 and sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau xy sin 2 theta. So to get the required normal stresses, the necessary sine and cosines of 2 theta p1 and 2 theta p2. ठीक है जी? Now here what we are doing for this orientation of the principal planes 2 theta p1 and 2 theta p2. So in this plane 2 theta p1, you can see this tau xy is tau xy is positive, and then this sigma x minus sigma y over 2 is positive. ठीक है जी? Sigma x minus sigma y over 2 is positive. And in this second value 2 theta p2 in the third quadrant, you can see tau xy downwards, so it is negative, minus tau xy. Then your normal stress minus sigma x minus sigma y over 2. So this is negative. So in the third quadrant, both your shear stress and the average normal stress, they are negative. ठीक है जी? So this will also give me the value of theta p2, and this one will give me the value of theta p1. ठीक है जी? So the construction of these triangles based on this equation, ठीक है जी? Assuming that tau xy, the shear stress, and sigma x minus sigma y, the difference of the normal stresses, they can either be positive or both negative quantities. ठीक है जी? And this was done on the basis that in the first quadrant tan will be positive, and in the third quadrant, in this quadrant, tan will again be positive. ठीक है जी, is this point clear?
Yes, sir.
And one more thing to be noted, this horizontal axis in this figure, the horizontal axis in this figure is your normal stress and the vertical axis is your shear stress. ठीक है जी, in the first quadrant, shear stress is positive and the average normal stress, difference of normal stress is positive. In the third quadrant, shear stress is acting downwards, negative, and this is also negative. ठीक है जी, so from here tan to theta p will give you two roots. ठीक है जी, one in which both can be positive and the other in which both can be negative. ठीक है जी, now basically how they are going to be related practically. So in practical, they are showing you this is your beam, ठीक है जी, and this is tested under one point loading, ठीक है जी, under pleasure you can say, and you can see these are the cracks which are shear cracks, ठीक है जी. If you I think you might have studied or maybe you are in process of studying in your PRC that these shear cracks they will be inclined at an angle. ठीक है, if you will have flexural cracks they will be somewhere near the mid span and they will be vertical. ठीक है जी, these are shear cracks. So the cracks in this concrete beam were caused by the tension stress. ठीक है, even though the beam was subjected to both moment and the shear. ठीक है जी, uh, but the shear failure is dominant here. The stress transformation equation can be used to predict the direction of the cracks and the principal normal stresses that cause them. ठीक है जी, so this is what you say they have practically linked the shear cracking in the beam tested under Fletcher, ठीक है जी, and you can calculate the normal stresses and the orientation of those principal planes over which these stresses will occur. Now the next thing is once we have this theta 2 theta p1 and 2 theta p2, next thing is we want to calculate the major principal stress and the minor principal stress. So what we want to do, we want to calculate the major principal stress and the minor principal stress. Just to derive that thing, just have a look over here. So you have tau xy and sigma x minus sigma y over 2. So it's the triangle. So using Pythagoras theorem, I can calculate the resultant of this. So resultant will be under root sigma x minus sigma y over 2 square plus tau xy square. ठीक है जी, so this will be my resultant. So do you agree with this resultant? आप लोग इस रिजल्टेंट से एग्री करते हैं ना? So resultant will be under root sigma x minus sigma y over 2 square plus tau xy square. Similarly, I can find the resultant, ठीक है जी, resultant stress for this second shaded triangle. So now again it will be under root. So you have minus sigma x minus sigma y over 2. So I will take the square of this. So this minus will basically minus will cancel out. Plus minus tau xy square. So this minus will again be cancelled out. So your final expression for the calculation of the resultant in both the cases will be this: under root sigma x minus sigma y over 2 square plus tau xy square. Do you guys agree with this?
Yes, sir.
Okay. Now, substituting these trigonometric values in equation 1. ठीक है जी। इक्वेशन 1 is sigma x dash is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos to theta plus tau xy sin to theta. So if you, let me take you there, let's say here. So you can see in this part there is no theta involved. However, in these two parts the theta is involved. So we will replace these two parts with the resultant. ठीक है जी, we will replace these two parts with the resultant. So my expression for the computation of the principal stresses, that will become sigma x plus sigma y over 2 plus minus under root sigma x minus sigma y over 2 square plus tau xy square. Always remember one thing, sigma 1 will always be your major principal stress. So the larger stress will be sigma 1 and the smaller stress will be your minor principal stress. So when I want to calculate major principal stress sigma 1, that expression will be equal to sigma x plus sigma y over 2 plus under root sigma x minus sigma y over 2 square plus tau xy square. And sigma 2 will be sigma x plus sigma y over 2, and over here it will be now negative. So sigma 2 will be equal to sigma x plus sigma y over 2 minus under root sigma x minus sigma y over 2 square plus tau xy square. Is this point clear? So this expression will give me the orientation of the principal planes, ठीक है जी? And this expression, which is equation 5, that will give me the major principal stress and minor principal stress. Always remember one thing, that the major principal stress will be your larger normal stress and minor principal stress will be your smaller or minor or minimum normal stress. So depending on the sign chosen or selected, uh, the equation 5 will give us the maximum or minimum in plane normal stress. ठीक है जी? Acting at a point क्या है, जो आपने plane state stress, you have selected one point and on that one element you are doing all the calculations. So sigma 1 will always be equal to or greater than sigma 2. Sigma 1 is sigma 1 will be my major principal stress, sigma 2 will be my minor principal stress. So this particular set of the values are called as the in-plane principal stresses. ठीक है जी? Sigma 1 will be your major principal stress, sigma 2 will be your minor principal stress, and uh, the planes on which these major principal stresses and minor principal stresses will be acting, these planes will be called as your principal planes. Principal planes are the planes over which your maximum and minimum normal stress will act. And moreover, over the principal planes, your shear stress will be zero. How can I get this answer? I will have two values of theta, ठीक है जी? Theta P1 and theta P2. What I will do, I will one by one put this value of, let's say, theta P1 in this equation. So I must get shear stress value 0. Similarly, if I put theta P2, I should get the value of shear stress equal to 0. And this we will do in a short while when we will solve the numerical. ठीक है जी? Now they have shown what you say is orientation of the principal planes on the element. So this is your normal element. ठीक है जी, sigma x, tau xy, sigma y. So all these normal and shear stresses are positive. So this is the orientation of the principal plane theta p1. So this is my x dash axis, ठीक है जी, and then theta p2 will be theta p1 plus 90 degrees, ठीक है जी. So I can just simply show this on the figure as well with the values which I will get. If you have any question about this part, please ask me now. If no question, then I'm proceeding further with maximum in plane shear stress. Now, just like you have calculated the major principal stress, minor principal stress, orientation of the principal plane, now you also have to calculate or compute orientation of the shear planes and the maximum in plane shear stress. Maximum in plane shear stress, ठीक है जी. Now to calculate this, the orientation of an element that is subjected to maximum shear stress on its sides can be determined by taking the derivative of equation 9.2 with reference to the theta, ठीक है जी, and setting the result equal to 0. So now the equation which we have derived earlier for the computation of the transformed shear stresses, that is tau x dash y dash is equal to minus sigma x minus sigma y over 2 sine 2 theta plus tau xy cos 2 theta. So I will take the derivative of this equation with respect to theta, and then I will equate this equation equal to 0, and I will get the orientation of the shear planes theta s1 and theta s2. ठीक है जी, I will get theta s1 and theta s2. So let's do this derivation. जी, is this slide visible to everyone?
Yes, sir.
Okay. Now tau x dash y dash is equal to minus bracket sigma x minus sigma y over 2 sine 2 theta plus tau xy cos 2 theta. So derivative of this is tau x dash y dash over derivative with respect to theta, that is equal to minus sigma x minus sigma y over 2. Derivative of sine is cos, so sine 2 theta, derivative of sine 2 theta will be cos 2 theta into the coefficient 2. ठीक है जी, coefficient 2 plus tau xy, derivative of cos 2 theta is minus sine 2 theta into the coefficient 2. So after simplification, derivative of tau x dash y dash with reference to theta, that will become equal to minus sigma x minus sigma y cos 2 theta. This 2 and this 2 will cancel out. Minus 2 tau xy sin 2 theta. ठीक है जी, minus 2 tau xy sin 2 theta. Then equating this derivative tau x dash y dash over d theta equals to 0. ठीक है जी, derivative, equating this derivative equal to 0. So your equation can be simplified as, so I will take this minus sigma x minus sigma y cos 2 theta on the other side. So now you can see sigma x minus sigma y cos 2 theta is equal to minus 2 tau xy sin 2 theta. Now in this equation you can see one of the coefficients, they are positive, and on the other hand the other coefficient is negative. ठीक है जी. Earlier both coefficients were like tau xy and sigma x minus sigma y were positive. Now in this case, one of them is positive, other is negative, and the other possibility is vice versa, that this is negative, this is positive. So I will now rearrange the coefficients. Sine 2 theta over cos 2 theta is equal to minus sigma x minus sigma y over 2 tau xy. ठीक है जी. So sine 2 theta over cos 2 theta will be tan 2 theta. So tan 2 theta will be equal to minus sigma tan 2 theta will be equal to minus sigma x minus sigma y over 2 tau xy. So this is over equation number 6, and you can have subscript theta s. ठीक है जी. So tan 2 theta s1 and tan 2 theta s2. ठीक है. And this is your what you say coefficient for the calculation. ठीक है जी. This is the coefficients with which you can calculate theta s1 and theta s2. ठीक है जी. So if you have any question about this, please let me know. जी, is this derivation clear? If you have any question about this derivation, please let me know. If this is clear, then we are proceeding forward. Just one thing to be noted here, that in this derivation, you have seen that either sigma x minus sigma y or tau xy, one of them will be negative. One will be positive, other will be negative. ठीक है जी. So let's move back to the book. Okay, so the orientation of an element that is subjected to the maximum shear stress on its sides can be determined by taking the derivative with respect to theta and setting the result equal to 0. So we got this equation which states that tan 2 theta s is equal to minus sigma y over 2 tau xy. ठीक है जी. Now again, the this equation tan 2 theta s, it will have two roots. So the two roots of this equation, theta s1 and theta s2, can be determined from this shaded triangle. Now to work with this shaded triangle, let's say I work first. Let's say first work with this one. Just note down one thing, that I have said earlier that one of this will be negative. So if I have this shaded triangle in segment 2, ठीक है जी, quadrant 2, so you can see the shear stress, it is positive. However, sigma x minus sigma y over 2 is negative, so that will give me theta s1, and 2 theta s2, that will be 180 degrees apart of 2 theta s1. So this one will be minus tau xy. So you can see the shear stress is negative now, minus tau xy, and this one is positive, sigma x minus sigma y over 2. ठीक है जी. So the two roots of this equation, theta s1 and theta s2, can be determined from the shaded triangles as shown in this figure. ठीक है जी. And we have shown theta s1 and theta s2 based on the fact that either sigma x minus sigma y over 2 will be negative or tau xy will be negative. One of them will be negative and other of them will be positive and vice versa. So by comparison with equation 94, ठीक है जी. ये इक्वेशन 94 ये है. ये इक्वेशन थी आपके पास tan 2 theta p is equal to 2 tau xy over sigma x minus sigma y. Tan 2 theta p is equal to 2 tau xy over sigma x minus sigma y. Now tan 2 theta s equation is minus sigma x minus sigma y over 2 tau xy. So basically they are saying that this equation is the negative reciprocal of tan 2 theta p. ठीक है जी. Negative reciprocal of tan 2 theta p. So by comparison with equation 1, that tan which has given us tan 2 theta p, tan 2 theta s is the negative reciprocal of tan 2 theta p, and so each root theta s is 90 degrees from theta to theta p. ये बात समझ आई है? ये क्या वो कह रहे हैं? Okay, just give me 1 minute. Let me finish this. Then I will draw the figure to let you know what they are saying. So by comparison, tan 2 theta s is the negative reciprocal of tan 2 theta p. So each root 2 theta s is 90 degrees from 2 theta p. ठीक है जी. And the roots theta s and theta p, they will be 45 degrees. So just note down one thing: 2 theta p1 and 2 theta p2, they will be 180 degrees apart. 2 theta p1 and 2 theta p2, they will be 180 degrees apart. Theta p1 and theta p2, they will be 90 degrees apart. Then 2 theta s1 and 2 theta s2, they are 180 degrees apart. Theta s1 and theta s2, they are 90 degrees apart. Then we are saying that 2 theta p1, 2 theta p1 and 2 theta s1, they are 90 degrees apart. 2 theta p1 and 2 theta s1, they are 90 degrees apart. So theta p1 and theta s1, theta p1 and theta s1, they will be 45 degrees apart. ठीक है जी. Therefore, an element subjected to the maximum shear stress will be 45 degrees from the position of an element that is subjected to the principal stresses. ठीक है जी. That will be subjected to the principal stresses. In a short while, we will do the numerical, and we will also prove that over this theta p1 and theta s1. Similarly, theta p2 and theta s2, they will be 45 degrees apart. ठीक है जी. Is this point clear?
Yes, sir.
Okay. Now next thing is we have to calculate the maximum in plane shear stress. So to calculate the maximum in plane shear stress, what you are going to do, you are going to place the resultant of this in equation number 3. Over is equation number 3, tau x dash y dash. So resultant of this shaded region will be placed in equation number 3, and we will get the final answer using either one of the roots, theta s1 or theta s2. The maximum shear stress can be found by taking the trigonometric values of sine 2 theta s and cos 2 theta s from equation 9 from the figure 910, and the maximum in plane shear stress we will get as under root sigma x minus sigma y over 2 square plus tau xy square. Now the only difference is in the major principal stress you had the formula sigma x plus sigma y over 2 plus minus under root sigma x minus sigma y over 2 square plus tau xy square, and in the maximum in plane shear stress you just have this result. ठीक है जी. So this value of maximum in plane shear stress is this will give us a maximum in plane shear stress value on the in the xy plane. ठीक है. Next, last point before we start the numerical, that is that calculate the average normal stress. Average normal stress, we can just simply calculate the average normal stress substituting the values for sine 2 theta and cos 2 theta into sigma x dash equation. We see that there is also an average normal stress acting on the planes of the maximum on the planes of this maximum in plane shear stress, where average normal stress is equal to sigma x plus sigma y over 2. Now the point to be noted here that the major principal stress and minor principal stress, these two major and minor principal stresses will act over the principal planes, and this maximum in plane shear stress and the average normal stress, they will act on the shearing planes. ठीक है जी. So maximum in plane shear stress and the average normal stress, they will act on the shearing planes. ठीक है जी. So what we can do, we can have a break of 15 minutes and we will restart the class at 11:05 with the numericals. Guys, are you back? Guys, are you back from the break? Let's start with the numerical. So the question statement is the state of the plane stress. The state of the plane stress at a failure point on the shaft, this is the shaft, is shown in the element in figure 911A. So represent this state in terms of the principal stresses. So this plane stress state condition of the element is shown to you. You can see there is 90 megapascals upwards, that is sigma y, positive 90 megapascals shear stress. The vertical component of the shear stress is acting upwards, so my shear stress will be positive. So shear stress is 60 megapascals positive. Okay? Then you have sigma x. Sigma x, it is pointing towards the negative x direction, so it is minus 20 megapascals. ठीक है जी. Now the state of the plane stress at a failure point on the shaft is shown in the element. So on the element you are given with the normal stresses and the shear stresses. So the question asks you represent this stress state. Represent this stress state in terms of the principal stresses. So we have to calculate the principal stresses, and other thing to be noted here that for the calculation of the principal stresses, major principal stress and minor principal stress, along with that we also need to calculate the orientation of the principal planes, that is theta p1 and theta p2. ठीक है जी. Let's start. Let's start. So first step is let's calculate the orientation of the principal planes. Orientation of the principal planes. Let's start with the calculation of the orientation of the principal. So formula for the calculation of the orientation of the principal planes is tan 2 theta p is equal to tau xy over sigma x minus sigma y. It's just downloading, just a moment for that. Okay. So sigma y is 90 megapascals. Sigma y is 90 megapascals. Sigma x is minus 20 megapascals. And tau xy is 60 megapascals, and it is positive. Is this clear, guys? ठीक है जी?
Yes, sir.
Now, first thing is you have to calculate the orientation of the principal planes. So please calculate tan 2 theta p, that is equal to 2 tau xy. Tau xy is 60, sigma x is -20, sigma y is 90. So please let me know the value of theta p1 and theta p2. Guys, there is one thing, just like we always take the larger normal stress as sigma 1. So major principal stress is always designated as sigma 1. Similarly, the minor principal stress is always designated as sigma 2. So over here, theta p1 will be your positive angle, ठीक है, and theta p2 will be your negative angle, ठीक है. So let's please calculate theta p1 and theta p2 and let me know the answers. So theta p1 and theta p2. So theta p1 and theta p2, please let me know the values. G. Everyone is getting the same answer. Theta p2 as -23.7 and theta p1 as 66.3 degrees. Everyone getting the same answers? What you can do, by just putting the value, you will get one value of theta p. That will be negative -23.7. So that will be negative -23.7. Then we know that the difference between theta p1 and theta p2 will be 90 degrees. So -23.7 plus 90 degrees, you will get theta p1 as 66.3 degrees. 66.3 degrees. Are we getting the same answer?
Yes, sir.
Okay. And can we represent this on the element? So this is -23.7, which means it is clockwise. Okay, so this is 23.7. Okay, the second angle we are getting that is 66.3 degrees positive. ठीक है जी, 66.3 degrees positive. So this is your x dash axis. ठीक है. So now next thing is we have, this was about the orientation of the principal planes. ठीक है. Now next thing is I have to calculate the major principal stress and the minor principal stress. So please let me know the values of major principal stress, that is sigma 1, and the minor principal stress, that is sigma 2. Ji, what is the value of sigma 1 major principal stress? What is the value of theta? What is the value of major principal stress sigma 1? Guys, you just have to put the values of sigma x, sigma y, and tau xy in this equation, and you will get your major principal stresses and minor principal stresses. Please let me know the value of sigma 1 and sigma 2.
Sir, sigma 1 is 116.394.
1 second. 116.39 megapascals कर लें. Two decimal places are sufficient. 39 megapascals. Okay. And sigma 2 is
minus 46.39 megapascal.
minus 46.39 minus 46.39 megapascal. ठीक है जी. Now the point to be noted here that the sigma 1 major principal stress 116.39 megapascals, that will act on the principal plane which is oriented at an angle theta p 166.3 degrees. My minor principal stress sigma 2, which is 46.39 megapascal, that will be oriented on the minor principal plane which is oriented at an angle 23.7 degrees clockwise. ठीक है जी. 23.7 degrees clockwise. So this was one way to calculate the major principal stresses and minor principal stresses. Now we also have this equation for the calculation of the transformed normal stresses, sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau xy sin 2 theta. So if I put the value of theta p1, which is 66.3 degrees, I should get this answer. Sigma x dash is 116.39, and if I put this value in this equation, I should get minus 46.39. So guys, in this equation sigma x dash, in this equation please put the value theta p1 is equal to 66.3 degrees. Please put the value 66.3 degrees in this equation and let me know the value of sigma x dash. जी बताएं. So you are putting theta p1 is equal to 3 degrees. You are putting theta p1 is equal to 66.3 degrees. ठीक है जी. And in the second case you will put theta p2. Theta p2 theta p2 as minus 23.7. ठीक है जी. So please let me know the value of sigma for this case. ये कितना आता है जी आपका sigma x dash?
Sir, same 116.39?
Of course same ही आएगा.
Sir, same value.
So sigma 1 is this is alternative method to calculate the major principal stresses and minor principal stresses.
Sir, same minus 46.39.
Megapascals. ठीक है. Now one more thing. We have said that this is over orientation of the principal planes, and we have said over the principal planes shear stress will be 0. तो आप ऐसे करें कि 66.3 using 66.3 find the value of the shear stress, transform shear stress. इस equation में put करें. Sigma x is minus 20, sigma y is 90, theta is 66.3, tau xy is 60, theta is 66.3. तो आपका shear stress 0 आना चाहिए. करें और बताएं. जी. You might get some rounding error, but in actual it should be 0. G. What's the value of the transform shear stress? Tau x dash y dash.
Sir, I am getting minus 0.12.
हाँ वो आपका राउंडिंग एरर आ गया. उसकी वजह भला क्या है मैं आपको बताता हूँ. उसकी रीजन है दिस एंगल द डिफरेंस ऑफ दीज टू एंगल्स शुड बी एग्जैक्टली 90 डिग्रीज. ठीक है ना. अगर आप इसको एग्जैक्ट 90 नहीं लेंगे तो यू विल गेट सम राउंडिंग एरर्स, बट इन एक्चुअल इट शुड बी 0. ठीक है जी.
Okay, sir.
ठीक है जी. So with this, anything else you want to know about this question? If you want to ask me anything else about this question, ask me. Or we can go to the book and we can go through their solution, and if there is anything additional they have found, that we can do as well. So you can, everyone can see the page of the book.
Yes, sir.
So you can see sigma x minus 20, sigma y 90, tau x y 60, theta p2 is 23 minus 23.7, theta p1 is 66.3. You have to ensure that the difference between these two angles should be exactly 90. Theta p2, theta p1, difference should be 90. Okay, then we have calculated the major principal stresses and minor principal stresses. As I have said earlier, as I have said earlier, that larger stress will be your major principal stress. So the same 116.4 we were getting megapascals, and it should be like 35 plus 81.4. You get it to 116.4 megapascals is sigma 1, and minor principal stresses is minus 46.4 megapascals. Next thing is the principal plane on which each normal stress x can be determined. So we have also determined. What we did, we put the value of theta p1 and theta p2 in this equation sigma x dash, and we got the values of the transformed normal stresses. So they were same as the major principal and minor principal stresses. Then we have sorry. Then we have also checked this, that no shear stress acts on the principal plane, and to an extent we got the value 0. ठीक है जी, the small values like 0.1 or 0.12 megapascals which you are getting, those values are basically because of the rounding errors. ठीक है. Is this point clear? Is this point clear, guys? If you have any query, please ask me now.
Yes, sir. But sir, I want to ask that for theta p1 and theta p2. So we are getting theta p and we are considering it as theta p2 and we are adding 90 to get theta p1. So can be these interchanged as 1 and 2?
Yes, yes, yes. See, the thing is, see, as you have seen this, you got the principal stresses sigma 1 the positive, sigma 2 the negative. ठीक है, अगर आप यहाँ पे उसको sigma 1 और sigma 2 को इंटरचेंज ना करते, तो आपका sigma जो था ना यहाँ पे आंसर, वो आपको चेंज करना ही है, बिकॉज sigma 1 is always the larger principal stress. ठीक है जी, और वो आपको 66.3 डिग्री इज गिविंग, वो आपको माइनस 23.7 डिग्री नहीं दे रहा. ठीक है, आपने जब इधर भी चेक किया है, आप सॉरी, जब आपने इधर दोबारा चेक किया है, तो आपने ये चीज नोट की है कि 66.3 degrees is giving you sigma 1 and minus 23.7 degrees is giving you sigma 2. ठीक है जी. तो आपको ये ध्यान में रखना है कि they can be interchanged, but they are interchanged on the fact that sigma 1 is always larger than sigma 2. ठीक है जी. Now the same question, the same data for which we have represented this stress state in terms of the principal stresses, the same data we are going to represent the shearing stresses. So the same question, same data. 90 megapascal sigma y, shear stress positive 60 megapascal, sigma x minus 20 megapascals. Represent this stress state in terms of the maximum in plane shear stress and associated average normal stress. So I have to calculate maximum in plane shear stress, and I also have to calculate associated average normal stress. And before that, I have to calculate थीटा S1 थीटा S2। ठीक है जी, सो लेट्स स्टार्ट गाइस। ठीक है जी, सो नाउ विद द सेम क्वेश्चन, so please calculate theta, please calculate